Hey guys, let's go ahead and get started. We're looking at section 8.5 and we're talking about angles of elevation and depression. To get a better sense of our vocabulary words today, which are angle of elevation and angle of depression, or I should say our vocabulary phrases, I think that this visual is most helpful. So if you use the pink lines as like your line of sight, if your line of sight is straight across and you are looking up, that would be called or considered an angle of elevation. Let me highlight that for you. An angle of elevation. And then if you are up high and you are looking down low, that is considered an angle of depression. All right. I think if you were copying notes, you want to draw little pictures to kind of help you keep in mind what's going on. But it's relatively straightforward, right? Okay. So here is where we're going to put all this angle of elevation and depression into a problem. So here we go. We've got this young lady standing here. She's at a castle at an amusement park. She knows a whole lot to not know how far she is from the actual castle, but we won't criticize the problem. We'll just go for it. So Leah's on vacation. She knows that the entire height of the castle is 190 feet tall. She knows that her angle of elevation, when she's looking at, is a 38-degree angle that she's making to tilt her head upward to look at the top of the castle. What we need to know is how far away the castle is. Now, I copied this picture out of the text. You need to be able to read this and make a representation not as detailed as this, but similar. You guys with me? All right. So that's why it says make a sketch to represent the situation. So I just chose to use the text sketch. Let's go ahead and fight for what we know. Now, the fact of the matter is we're still using our identities, our trig identities. So we've got sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. And I don't like that line there. And let's make it red. Okay, good. All right, so now that we've got our little handy cheat sheet there, let's go ahead and think through how we'll solve this problem. So we know we need to find x. So basically what I want to highlight for you guys is this triangle right here. This triangle right in here, which I know you see. We're going to use right angle trig with this triangle. So we're going to use what we've got, which is this side, to get what we want, which is this side. So hopefully you know that opposite and adjacent means that we should use tangent. So we'll be talking about the tangent of 38 degrees. The tangent of 38 degrees is not equal to 190 over x. It is equal to opposite over adjacent. X is the denominator, but that 190 isn't. Can you figure out why 190 is not the length of the side of the triangle that we're concerned about? Hopefully you realize that it's the height of the castle, but remember that she's 5'5", or not 5'5", 5.5 feet tall rather, and that she cuts off some of the part of the triangle just by her height. Do you see what I'm talking about? So right here, that's 5'5", as she's 5'5", so we're going to take 5'5" off the entire height of this side of the triangle. Hope this is making sense. So 190 minus 5.5 is going to be 184.5. So this is the formula that we're going to work on to solve for x, to figure out her distance from the castle. So we're going to, I like to get the x out of the denominator. So I'm going to do my famous, take the reciprocal of both sides. It's still equal. Because if you take the reciprocal of one side and you take the reciprocal of the other, or I'm going to say it in layperson's term, if you flip the fraction on one side, it's the same as flipping the fraction on the other. And now this is going to make our solving for x easy. We're going to multiply both sides by 185.5. And when I do that, watch this, 185.5. I'm sorry, you know I meant 184, children. 184.5 and times 184.5 on this side, I get that x is equal to 184.5 divided by the tangent of 38. And you remember from last time we talked, the reason why we like to do that is to make everything calculator ready, whether you're using Desmos or your cell phone calculator, whatever the situation may be. You want to make sure and get your information calculator ready. You see me searching for my calculator as well. So here I am hanging out at Desmos. I've got the information here. Let me click over really quick. 184.5 divided by the tangent of 38. Let's do that. I legit just typed that in, 184.5 divided by the tangent of 38, and I got this number. What were we trying to find again? I was trying to find x. Could she have been 500 feet away? I mean, maybe, right? So sometimes when you're dealing with your trig functions in a calculator, particularly, you need to make sure your answer makes sense, or even more importantly, make sure you're in the right form. Where in radians, I need to be in degrees. Look at how my answer changed. 236.14 is the answer. That's about how far away she is. And that kind of jives with the picture that we have. But if you were drawing your own picture, you may not have known that. So you want to make sure and not just plug everything into your calculator, but make sure you're in degrees if you're dealing with degrees, which we will be. So the answer, I just lost it again. The answer was 200 something. Let's see. 236.14. Or let's just say 236 feet, because they did ask us to answer it to the nearest foot. All right, so here we go. We have an example entitled Emergency. So here we're looking at, and you can just glance at the picture. Again, this is something that you would need to be able to do just from reading. I should kind of white this out, but let's see if we could read and see how the picture was created. A search and rescue team is airlifting people from a scene of a boating accident when they observe another person in need of help. So people are being airlifted. Here's this person in need of help. If the angle of depression to this person is 42 degrees, right? Line of sight is this way. Angle of depression is this way. And the helicopter is 18 feet above water. What is the horizontal distance from the rescuers in to this person in nearest foot, to the nearest foot? So we're looking at this particular distance here, this x. So hopefully you feel confident that you'd be able to do that in terms of using the information to draw a quick triangle that can represent the situation. Let's see what we need to do. We're standing at this angle. We're still going to keep in mind our memory, I'm going to say our memory device. Well, I guess our memory device, yeah. That we're going to, our mnemonic device, Soka Toa, to help us remember the relationships. And we're going to use what we've got to get what we want. And this looks like another opportunity to use tangent. The tangent of 42 degrees is equal to, in this case, it is equal to 18 over x. And so now what I want you to notice, because they didn't talk about this angle here, but the angle of depression has to equal this angle here. And I think that was the key part of the problem, recognizing that if the angle of depression is here, and if you make the triangle on, you could have made the triangle here and then found the distance here. But if you make the triangle like this angle too must be the same thing. And you might notice it because parallel lines cut by a transversal, alternate interior angles are equal. You didn't think that stuff was coming back, did you? But it is. All right. So now that we've got that, we're going to solve this like we did the last one. Take the reciprocal of both sides. X over 18 is equal to 1 over the tangent of 42. Therefore, multiply both sides by 18 and I get 18 over the tangent of 42 is equal to x. I'm going to take a trip over to Desmos and I'm going to calculate this by simply putting in 18 divided by the tangent 42. Now I'm confident that we're in degrees, so I don't need to go and check that. I got 19.99, which is basically, 20 feet. So we can conclude that x is equal to approximately 20 feet. And so that's the horizontal distance there. Here's our final example, and nope, that's not what I want. Here's our final example, and it's going to take a little while. So I'm going to first start off by just talking about, let's read the picture, read the problem before we take a look at the picture, and let's see if we can kind of ascertain what's going on. So we have a situation where Mrs. Long is looking at a tree in her backyard that she wants to remove, and I'm assuming it's in her backyard. I don't know where this tree is. She just wants to remove trees. Okay, so she's looking at a tree supposedly in her backyard that she wants to remove. The angle that she needs to tilt her head to look to the top of the tree is 70 degrees. And then if she takes a few steps back to about 10 meters, her angle of sight becomes 26 degrees. Her height is 1.7 meters above the ground. How tall is the tree? So when I'm thinking about this, as I think about this, I see two triangles stacked on top of each other. One is where Mrs. Long is here, and the other one is where she's, well, let me move that back a little bit further, where she's 10 meters away. So the tree is here, because this is what trees look like, and that's 70 degrees. And then over here, she steps back, that's 26 degrees. And all we have in terms of this width is that this is 10, and we know that. Do we know the height of the tree? Let's see. She needs to take, oh, I don't think we even know that. So this is going to be a variable, and this is going to be a variable. So this is going to be like a party. So I've got, this is the general image, and now I'm going to erase this so we can look at the pretty image. The beautiful drawing that the textbook company has put together for us. So here's our two triangles. Here's Mrs. Long. Here she is at this height. We want to know what X is. What are we trying to find? How tall is the tree to the nearest meter? So we're looking for all of this. We're going to find X, but we're going to eventually have to add Mrs. Long's height to X. Just keep that in mind in order for us to find the height of the tree. Well, now we've got this angle and this angle, which tells me that we should be trying to find as much information as we can about X and Y related to our trig functions, relations, whatever. And so again, it looks like since we don't have any information about the hypotenuse, we're definitely using tangent. So if you can do this, tangent of 26 degrees would be what? Take a second, pause me, think about it. It would be X over 10 plus Y. Because 10 plus Y is the side of this triangle. And this next one is a little bit easier. The tangent of 70 degrees would be X over Y. Right now you might be frightened because we got all the information we can from the picture as yet, but we shouldn't be afraid. We can handle this because this is just a system of linear equations and we know how to deal with that, right? So when we have a system of, well, not linear equations because they're not, well, they are actually linear. They would be linear, but it doesn't look like it now. You've got tangent, which seems weird. Remember, tangent of 26 is just a number. Tangent of 70 is a number. So it's like 5 is equal to X over 10 plus Y. 7 is equal to X over Y. We could solve this, but I want to make it calculator ready. So I'm going to do a lot of algebra here. So watch what I'm going to do. I know I need to substitute because I need to solve one equation with one variable. So I'm looking at this situation here. I'm thinking X is easy to substitute, is to solve for. And it is because I can just multiply both sides by Y. So X is equal to Y times the tangent of 70. Are you with me? Multiply both sides by Y. And you know what happens when we do that? We take that thing and we plug it in for the variable into the other equation. So our new equation is going to look like this. Watch. The tangent of 26 is equal to not X, but Y times the tangent of 7D, all of that over 10 plus Y. Right now, you're still not feeling happy. You're still wondering why I'm doing this, but just bear with me. I want you to sit down and just look at the truth of this for a few moments, and we're going to pick this back up in the next video. I promise it'll make sense. Just take your time, and if it doesn't feel good, we'll talk about it in a minute, but I'm going to end the video here. Make sure this makes sense. We'll start up again as soon as you click on the next video.